Greetings, my name is Romanda Miller with Loughborough University, and I'll be discussing relationships between whole body kinematics and a badminton jump smash racket head speed. Badminton is a game of quick movements and reaction. The badminton smash is an effective attacking shot within the game, accounting for 54% of all winning shots within international matches. A shuttlecock with greater post-impact speed would give an opponent less time to react and therefore less time to return the shot. The smash is a power stroke that is used to gain a point advantage over a player. Jumping while performing the smash is the most popular technique within the men's game. Previous research has reported that linear velocities of the distal segment best explain variation within shuttlecock and racket head speeds. However, it is unclear how those distant segment velocities and therefore the racket head and shuttlecock speeds are generated. While badminton is a popular sport, few studies have investigated the kinematic determinants of the racket head speed within a badminton smash by elite players. To identify full body kinematic parameters that best explain the generation of pre-impact racket head velocities within the badminton jump smash was the purpose of this study. 18 male badminton players of a regional, national, and international standard participated in the study. An 18-camera Vicon motion analysis system collected 3D kinematic data for the participant, racket, and shuttlecock across the badminton court. 44 retroreflective markers were attached to each participant and positioned over bony landmarks. Each racket was fitted with 7 strips of reflective tape around the face, placing a marker on the base of the racket. Yanet's AS40 shuttles were used for all players and was attached with a strip of reflective tape to the base of the shuttle. The players were given a warm-up period that allowed them to get used to the marker and testing conditions. Each player used their own racket for the testing session, and they performed 12 forehand smashes that was racket fed to them from an international coach or player in order to represent match conditions. The best trial with maximum velocity and minimal marker loss were identified for each participant. These trials were manually labeled and processed using Vicon nexus. There were several key instances and phases that were found to be important when performing a badminton jump smash. These key instances were calculated and used to gain a better understanding of the relationship between technique and racket head speeds. The preparation point was defined as the point in which the center of mass height was minimal for a participant. The end of retraction point was defined as the point in which the racket was most medial-laterally positioned toward the non-dominant side of the participant within a global system. The racket lowest point was the point in which the racket tip was at its lowest vertical point. Turning point was the point occurred after the racket lowest point, at which the racket head velocity, normal to stream bed, became positive. And the shuttlecock contact was the closest motion capture frame to the previously defined instant of racket and shuttlecock contact. Along with those key instances was 2 phases that were deemed important when performing the badminton jump smash. The backswing phase is the time it took a person to get between the preparation point and the turning point, while the acceleration phase is the time it took a person to get between the turning point and the shuttlecock contact. Again, these are the key instances and phases identified and calculated for this study. 37 kinematic variables were identified and calculated. Pink linear velocities of the joint centers, shoulder, wrist, elbow angles, jump height, and phase duration. They were all calculated at the key instances and phases and found how they correlated with racket head speeds. The significant value was placed at 0.05. Racket head speeds achieved by the participant in this study show good agreement with previously reported values by elite players. Peak linear velocity of the wrist joint center was found to be a strong predictor of racket head speeds, indicating that players should ultimately aim to achieve high linear velocities within distal components of the kinetic chain. The kinetic chain principle is when movements of a proximal to distal nature generate and conserve angular momentum to produce high distal endpoint velocities, in this case, the racket head speed. Jump height correlated with racket head speed. It is thought that jump height in the smash is a characteristic of a more able players attempting to produce steeper smash strokes. Those players with a higher jump height in this study had the fastest speeds. Greater racket head speeds were also produced when the acceleration phase was shorter in duration. In this study, it is found that the players, where the racket head speed become positive much closer to impact at the fastest speeds. And greater shoulder internal rotation at shuttle contact was also shown to have correlated with racket head speeds. This suggests that the shoulder internal rotation puts the arm in a better position to generate wrist and consequently racket and shuttlecock speeds. This is suggestive of the kinetic chain principle that was discussed earlier, in that the shoulder produced the momentum needed for the wrist to generate the final velocities needed to produce those final racket head speeds. This study has shown that greater peak wrist joint center linear velocities, jump height, shorter acceleration phase, and greater shoulder internal rotation at shuttlecock contact were all found to have a significant correlation with racket head speeds. It is suggested that players and coaches should aim to decrease the length of acceleration phase of the racket through technique and strength in order to create the racket head speed. The techniques talked about in this research can be used to generate those faster speeds. These two videos are representative of the fastest and slowest person used within our trial technique. For further information and more detailed work, please check out our published paper on open access. Thank you.